Unit 4 notes, nonlinear inequalities. What we're looking for today is we're trying to solve what values of x are going to make this function less than or equal to 0. I don't believe they provided us with enough room on this piece of paper that you will be given. So I'm going to use a separate sheet of paper to work this out. Now, one way to solve these types of problems is think of a number line. First of all, factor. Make sure you factor the problem. Hopefully you realize that that's what we're doing a lot this unit. Factor, factor, factor. So this function would factor accordingly. And if you set each of these factors equal to 0 and solve, you would get -5 and +1. Well, this is what they could look like on a number line. Now, here's what we want to do. We want to think, what number would appear right about here on the number line in this example that we provided? And we could say -6, right? You could truly use any numbers that are less than -5, but let's use numbers that are very close to -5. So we want to use -6 to help us solve this problem. Then we want to pick a number in between -5 and +1. Let's choose 0. Anytime you can use 0, you want to use that. And then you want to use any number that is greater than 1. Let's use 2. So these are the numbers that I'm going to use to help me solve this problem. And now what you want to do is you want to simply plug them into the function. And I'm not necessarily going to plug them in great detail. I'm going to solve them. You know what? Let me just do it, and then I think it'll make sense. Okay, so if we took -6 and plugged it in here, -6 plus 5 is -1. -6 minus 1 is -7. Now, -1 times -7 is +7. So here's what we know. Anything that is less than -5 is going to result with a positive number. Okay, now let's use 0. If I took 0 and plugged it in here, 0 plus 5 is 5. 0 minus 1 is -1. 5 times -1 is -5. So what that means is anything in between -5 and 1 is going to be a negative number. And now we're going to use 2. So if we took 2 and plugged it in, 2 plus 5 is 7. 2 minus 1 is 1. 7 times 1 is 7. That's a positive number. What that means is anything greater than 1 will result in a positive. Now here's what we're looking for. Look right here again. We need values that are less than or equal to 0, less than or equal to. So we're looking for a negative result here. So our solution is going to be right here. And we're going to need to use brackets because it's telling us since it's less than or equal to, it can include -5. It can include 1. So your final answer for this example would be, and we're going to write it in interval notation, bracket -5, comma 1, bracket. That is your answer for the first example. Example A. They have already factored this one for us. That's nice. So if we set that equal to 0 and solve, we would get -2. If we set that equal to 0 and solve, we would get +3. This is what that could look like on the number line. Okay, so let's use the same strategy that we used earlier. What's a number that is less than -2? Let's use -3. A number in between -2 and +3, let's use 0. And a number greater than 3, let's use 4. All right. So take -3, plug it in here. -3 plus 2 is -1. -3 minus 3, -6. Negative times a negative, that is a positive. So everything less than -2 is going to result in a positive number. We took 0 and substituted it. 0 plus 2 is 2. 0 minus 3 is -3. Multiply the 2 together to get -6. Anything in between -2 and 3 is going to be a negative number. Take 4, substitute it. 4 plus 2, that is 6. 4 minus 3, that is 1. 6 times 1 is 6. Anything greater than 3 is going to result in a positive number. So this answer is going to look a little different from the previous one. What are we looking for? Oh, yeah, sorry. We're looking right here. I was wrong. This one's going to look somewhat similar. I was thinking of something else. Sorry. We need all the values where x is less than 0. that is going to occur right here. Since everything in that would produce a negative result, that's where all values of x are going to be less than 0. Now, since it's less than, and we don't see an equal to sign, also notice that I use open circles here. That means it cannot include -2. It cannot include 3. So in interval notation, we're going to need to use parentheses now. That's where this one's going to be a little bit different. That is your answer for example A. Example B. Take these, set them equal to 0 and solve, draw up a number line, plot them accordingly. Note that less than or equal to, so all of these are bubbled in. Okay, now we're gonna have to work with a little bit more numbers this time. We need numbers that are less than -5. So let's use -6. A number in between -5 and -1. Let's use, how about -3? A number in between -1 and 4. Let's use 0. And a number greater than 4. Let's use 5. Let's start solving. Okay, so if we took -6, substituted it here, that would be -6 plus 5. That's -1. But -1 in parentheses squared is going to be +1. -6 minus 4 is -10. -6 plus 1 is -5. We multiply all this together, +50. So everything less than -5 is going to result in a positive number. Now let's use -3. We took -3, plugged it in here. -3 plus 5 is 2. 2 squared is 4. -3 minus 4 is -7. -3 plus 1 is -2. Now, if you get to a point where, okay, 4 times -7, okay, that's -28. -28 times -2. What is that? Well, it's 48, isn't it? But here's the most important thing. Really, the numbers that we get once we multiply doesn't matter. What matters is it negative or positive? Negative times the negative is going to be a positive every time. So really, that's the most important part. You don't even really need to know what the number is. You just need to know, is the number going to be negative or positive? Anyway, I wanted to just point that out, because that's probably going to help us in the future at some point. Let's go with another number. Okay, let's now use 0 here. Took 0, plugged it in. 0 plus 5 is 5. 5 squared is 25. 0 minus 4 is -4. 0 plus 1 is 1. A positive times a negative times a positive is a negative number. Forget about that number. We know it's going to be negative. So everything in between -1 and +4 is going to be negative. And now let's take 5. 5 plus 5 is 10. 10 squared is 100. 5 minus 4 is 1. 5 plus 1 is 6. Multiply. Notice these are all positive. So we're going to get a positive number. So everything greater than 4 is positive. Okay, now let's go back here. What are we trying to solve for? Less than or equal to. Less than or equal to. This zone here is where everything is negative or everything is less than. And since it can include, we want to use brackets here. So final answer would be all values of x in between -1, including -1, and +4, including +4. Example C, make sure you factor. Once you factor, set them equal to 0 and solve. Plot on your number line. We need a number less than -3. Let's go -4. We need a number in between -3 and 5. Let's go with 0. And we need a number greater than 5. How about 6? Okay, let's start solving. Plug in -4. -4 minus 5 is -9. -4 plus 3 is -1 for a result of +9. So everything less than -3 is going to result in a positive number. Let's use zeros. 0 minus 5 is -5. 0 plus 3 is 3. And -5 times 3 is -15. Everything in between -3 and 5 will result in a negative number. Plug in 6. 6 minus 5 is 1. 6 plus 3 is 9. 9 times 1 is 9. So everything greater than 5 is going to result in a positive number. What are we looking for here? Oh, this time we're looking for everything greater than or equal to 0. So we're looking for positive results. It can include -3 because greater than or equal to, but we're covering everything that is less than or equal to -3. Remember, this direction is negative infinity, and over here, this direction is positive infinity. So hopefully that will help you with your interval notation on these types of problems. We want to go from left to right. So everything start with negative infinity, approaching -3. It can include -3, so give it a bracket. Union, we're going to pick up here at +5 and go all the way to positive infinity. That is your answer. Example D. All right, something that I need to point out here is example D. We're dealing with a rational function now. Remember, what's on top of the fraction helps you identify an x-intercept. Set that equal to 0 and solve, you'd get -2. Since it can include -2, greater than or equal to, use a circle. Now, anything on the bottom of a fraction helps you identify a vertical asymptote. Set x minus 4 squared equal to 0 and solve, and you get +4. Note that rather than putting a coordinate there, I put a dashed vertical dashed line. That lets me know we're dealing with an asymptote here and not a coordinate, not something that x can actually be. But we're going to solve it in much the similar way. We want to pick a number that is less than -2. A number in between -2 and +4, and then a number greater than 4. Then we're going to start solving. So -3 plus 2 is -1. -3 minus 4 is -7, and -7 in parentheses squared is +49. That's going to result in a negative number. -1/49. So everything less than -2 is going to be a negative number. Take 0, plug it in. 0 plus 2 is 2. 2 minus 4 is -2. And -2 in parentheses squared is +4. That is going to result in a positive number. Everything in between -2 and 4 will be positive. And now let's choose 5. Take 5, plug it in. 5 plus 2 is 7 over 5 minus 4 is 1, and 1 squared is 1. That's going to result in a positive. So everything greater than 4 will be positive. Let's go back to what are we solving for? We are solving for greater than or equal to 0. So we need positive results. That is going to be in this range here. And it can include -2, bubble, and here. Cannot include 4. That's what the vertical asymptote means. So this range is positive. This range is also positive. So also from here, I'm going to put a union there all the way to positive infinity. Okay, so now we can build our final answer here. From -2, it can include -2 to +4, but it cannot include +4. So give it a parenthesis. And then from +4, but not including, all the way to infinity. That would be your answer for D. Example E, factor, factor, factor. Remember, anything on top is going to help you find x-intercepts. So we have an x-intercept at 6. Since this is greater than, we see no equal to sign. We see no equal to sign. That's the reason why these are now open circles here. So we have an x-intercept at 6, an x-intercept at -1. We have a vertical asymptote at x equals 0 and x equals 3. We're going to have a little bit more numbers to work with here, but that's okay. So we need a number less than -1. Let's use -2. A number in between -1 and 0. Oh my goodness, what are we going to use? How about -1/2 or -0.5? Doesn't matter. In between 0 and 3, how about 1? That's an easy number to solve for. And then a number, 0 and 3, a number in between 3 and 6. Let's go with 4. And a number greater than 6. Let's go with 7. Okay, let's start plugging in. You know what I'm going to do here? I'm just going to worry about signs. I'm going to take -2, plug it in here. -2 minus 6 is -8, but I'm just going to say, hey, the number's negative. That's the most important part. -2 plus 1 is -1, another negative number. Over, well, -2, that's a negative, times -2 minus 3, that's -5, another negative number. So we have a negative times a negative. These are now positive. Negative times a negative. These are now positive. So everything less than -1 is going to result in a positive number. Okay, now -1/2. This is where this trick really comes in handy. -1/2 minus 6. Who cares what the number is? We know it's still going to be negative. So -1/2 plus 1. Well, that would result in positive number. Over -1/2 -1/2 minus 3, that would still be a negative number. If we multiply this out, a negative times a positive is a negative, over a negative times a negative is a positive, and a negative divided by a positive number is a negative number. So everything in this range is going to be negative. All right, now here, we take 1, plug it in. 1 minus 6 is -5, negative. 1 plus 1 is 2, positive, over 1, that's a positive number. 1 minus 3, that's a negative. Negative times a positive, that's a negative number. Positive times negative, that's a negative number. And a negative divided by a negative is a positive. So everything in this range is going to result in a positive solution. Okay, now let's use 4. 4 minus 6 is -2. That's a negative result. 4 plus 1 is 5. That's positive. Over 4, it's positive, times 4 minus 3, that is positive. Negative times a positive is a negative. Over a positive times a positive is a positive, and a negative divided by a positive is a negative number. So everything in this range is negative. Last number. 7 minus 6, that's a positive number. 7 plus 1, that's a positive number. I'm sorry, 7, we're plugging the 7 here, that's a positive. 7 minus 3, that's a positive. Looks like we're going to get a positive result here. So everything greater than 6, everything in this range here is positive. Now we're going to go back here and figure out, okay, what are we looking for? we're looking for everything greater. We're looking for positive results. So that's going to be this range here, not including -1. It's going to include from here to here. And then it's going to include from here to here. So let's start constructing our final answer from left to right, beginning with -infinity, comma -1, not including -1, 0 to 3. And then 6 to infinity. That is your answer. Example F, factor, plot, and then start coming up with your numbers. So a number less than -5 is -6. The number in between -5 and -3, let's just go with -4. A number in between -3 and +3, let's use 0. And then a number greater than 3, 4. -6 plus 5, well, that's a negative number. Over -6 minus 3, that's a negative number. -6 plus 3, that's a negative number. So it looks like we're going to have a negative times a negative. That's a positive for a negative result. Everything less than -5 is going to produce a negative answer. Let's use -4 now. -4 plus 5, that's positive. -4 minus 3, that's negative. -4 plus 3, that's negative. So it looks like everything in this range is going to produce a positive result. Let's plug in 0. 0 plus 5, well, that's a positive number. 0 minus 3, that's negative. 0 plus 3, that's positive. So everything in that range is going to produce a negative result. Let's take 4 and plug it in. 4 plus 5, that's a positive number. 4 minus 3, that's a positive. 4 plus 3, that's a positive. Now let's go back here. What are we solving for? Less than. So we need negative results. It's going to be this range here. And there. That's your final answer. You know what? I just realized that I was showing you how to do math, but I wasn't showing you how to fill in these blanks here. So if you would pause the video, write this stuff in there. And then this is the stuff that should be on the first page. And now the word problem. From November 2003 until March 2004, Walmart stock was worth approximately, and then it gives you an equation where P denotes the price of the stock in dollars and T corresponds to months. November 2003 is represented by T equals 1. So I made a note here. November is equal to 1. And then they say December is equal to 2, January is equal to 3, and so on. So February is 4, March is 5, and et cetera, et cetera, et cetera. During what months was the stock value at least $54? So you have to take the function it gave you, and it needs to get to a point where it's at least equal to, greater than or equal to $54. So you're going to want to use a greater than or equal to sign here. Now, in order to solve, we have to set it equal to 0. So we're going to combine like terms. once we simplify, 70 minus 54 is positive 16. And now we are set equal to 0. Here we can factor out a 2. And now we can factor this trinomial. Now we know we could construct our number line here. We know that we have an intercept at 4 and positive 2. 2, positive 4. Greater than or equal to, so we could use solid bubbles here. I'm running out of room. Let me use a separate sheet of paper. Okay. Well, we're going to do what we did this entire video. Let's pick a number less than 2. Let's use 1. Let's pick a number in between 2 and 4. Let's use 3. A number greater than 4. Let's use 5. So if we took 1, substituted here, 1 minus 4, that's a negative number. I'm going to include the 2. This one's a little bit different because we have a 2 there in front. 1 minus 4, that's a negative. 1 minus 2, that's a negative. You multiply all this together, that's a positive result. Let's use 3. 2 times, well, 3 minus 4 is a negative number. 3 minus 2 is a positive number. You multiply all this together, we're going to get a negative result. All right. Now take 5 and plug it in. 2 times 5 minus 4, that's a positive. 5 minus 2, that's a positive. Multiply all this together, we're going to get a positive result. Now, let me go back to the word problem. What are we actually solving for here? During what months was the stock at least $54? So it can be equal to 54 or greater than. We need at least that amount, but we can have more than amount. So we're looking for positive results, right? This is where it's positive. So since we're dealing with months here, it gave us all these months. There's only one answer that doesn't apply for, the third month. And what's the third month represent? January. So it applies for every single month except January. All of them except January. That's your answer. Have a good day.